Hi, gang, Matt, 6620. I hope you don't think this video is a waste of time because we don't really, uh, let's just let it play out. We've used this OT grant data set, and I've renamed it a little bit, just OT grant DFA for discriminant function analysis. And if you remember in one of the previous videos in one of the previous lessons on logistic regression, we ran a backward elimination model, and the variables that were retained were age, meds, and just the ones that are listed here. So what I did when I agreed to analyze the data for this grant, we really struggled with the way that we classified falls. If we looked at fall counts, the distribution was nowhere near um, symmetric, and we were going to have to use some transformations. I always steer clear of those if I can. We had a kind of a natural ordering of fall status in that the patient never fell, or they fell one or more times. Yeah, I don't know. I had some problems with that because to me, there's a big difference between falling one time in a month and 22. So when predicting fall status, we struggled with that. Um, Another approach that I considered was looking at falls in terms of no falls, one fall, and then two or more. Um, and I considered that, and that certainly would have moved us into the discriminant function analysis family. So anyway, what I did, let's just run through it, and I want to show you the way this plays out. This is the title of this should be "Welcome to My World," because this is what happened with the occupational therapy data set. I think it's interesting enough to share with you. So, the very first thing I need to do is as always, identify what the reference category is for my dependent variable. Now, I'm using false status. So if you see false status, it is dichotomously coded, so it's appropriate for um, false, yeah, logistic regression. Okay. Um, so what I did first of all is I ran my model using logistic regression techniques, and you can see that I get statistical significance on for the predictors. And then I create my null model just to examine if this model is a significant improvement over the constant only model. And we see that it is. It's statistically significant at the 0.001 level. The next thing I wanted to do is just dive into the model accuracy. And unfortunately, the percentage of accurately classified cases is only 63.9%. So the next thing I did is I dove into and again, I'm replicating that. I ran this code this morning, and this actually I crunched the data on this study, I don't know, 7 or 8 years ago. So this is not the R commands that I used. So anyway, I wanted to explore the linear discriminant function analysis. So there's a couple of tables that I have to uh, uh, install, rattle, and heap lots. Heard someone call that hep lots one time. So yeah, whatever. So the first thing I need to do is check the equal variance covariance assumption over the independent variables fails miserably. So our focus should immediately turn to quadratic discriminant analysis. Next thing I do is I start the process for creating my training set and my test set. And we've talked about that previously. So I start sampling, and then my training set where I'm going to run my model on, and my test set, what I'm going to test my model, have been clearly defined. So access mass package to be able to run the QDA or LDA. You can see that I've done that on the training data set, and we get our model. Now, get into predictions, and unfortunately what I ran into years ago and what I'm demonstrating right now is that the model classification was extremely poor, only 22%. When I look at this, that 19 and this 10, you look at the diagonal. So I only had 11 of the total cases here in the test data set that classified correctly. Just like I had 19 patients who did not fall, but we predicted them to fall one time. This 10, we had a patient who fell 2 or more, and we only predicted them to fall once. So that's a little bit of an issue. And I will tell you another issue that I knew we were going to run into problems early on is when running discriminant function analysis, we really need the counts in the levels to be pretty close. And I'm pretty sure that we all agree that 49, 53, and 142 are not close. Well, the 49 and 53 are, but not across all levels. So are in the QDA, again, extremely low percentage of accurately classified cases. The next thing I did, I want to demonstrate this. So I'm going to go down to the bottom and go back up and get it. Right there, yeah. And I demonstrated this plot previously, but it's a lot more exciting when we have more than 2 predictors. And what it does, let me give it time to. Is it runs the classification tables for each of the pairs of predictors. It's going to take a while because we had a lot of pairs. I just hope that my computer doesn't crash. So if you were presenting the summary of these results, these tables are something that you would want to include. And in fact, I'm going to show you another table that I actually prefer more. I think these get a little cluttered. But I like this, that it gives the approximate error rate for each of the pairwise. So anyway, what do we have here? We have the reds, which are, the blacks, which are accurately classified, and we have the reds, which are not. All right, so I'm going to put a stop to this, if it'll let me. Didn't want to go away. All right. So the next thing I did here is I want to run the linear discriminant function, even though the assumption was violated. I want to do this just from a teaching perspective. And I ran this again on the same predictors. The data said train, and of course ran my predictions on the test model. And we can see that the percentage of accurately classified cases was about 47%. So what went wrong? So there are some additional assumptions that I want you to put on your radar. First of all, the number of cases in each group should be close. What's quote unquote close? Just eyeball it. It should be close. And we don't have that. Next thing, we need a larger sample size. General rules, we need 4 times as many samples as there are independent variables. I think we had about 8 predictors or 9 predictors, so we need a sample size of about 36, and we beat that by a long way. Number 4, highly sensitive to outliers. I didn't check for outliers here because once I violated the multivariate normality assumption, I didn't dive into that. But that's something you would want to do, is dive into the see if you have any high outliers across the predictors. Next thing I did is I have a plot that I prefer, and this is the one that I would encourage you to use, especially if you're running a linear model, linear discriminant analysis model. And you have to install ggplot2. We've already installed it, so I'm just accessing the library. And let me just go back up and get it. I think this is it. It turns out really nicely. LDA data, all of this stuff should be, well, I created LDA data right here by binding the predictions for the model over the independent variables, the predictors for the train data set. And then I just come in and access this code. Um, So I just use the LDA data that I created up here, and the rest of it is just telling R how I want things labeled, what colors we want to use. And I want the colors to be different across our dependent variable. All right, so if I click that, you'll see that all right, finally. You see that we don't get the discriminant analysis. We don't get the linear or quadratic regions, but we still get a pretty good indication that there's uh, not a lot of clusters of our red, green, and blue dots. So we get some with red, but there's yeah, just it's going to be hard to fit this model. So circling back, what did I do? I scrapped the discriminant function analysis approach and just ran with um, the logistic regression. And you know, these people paid us a lot of money to run this study and to analyze the data, and I really wanted something good for them, but we just didn't find it. Okay. So the next video I'm going to post, I'm actually going to create a data set that where the assumption is not, the variance covariance structure is not violated, and, and run through an example and show you the key parts that should be reported in the write-up. All right, take care.